Good day everyone, Mr. Cargill here with our next AutoCAD video. For this video we're going to be looking at how we go about drawing a triangle equal in area to an irregular pentagon. And this same method can be used to draw a triangle equal in area to a regular pentagon as well. Alright, now for this drawing here, alright, it says that we're going to draw the pentagon first. So this is the pentagon here, A, B, C, D, E. It's two stages, stage 1 and stage 2. So here, the first thing we have to do is to draw the pentagon. Alright, it says that AB equals 50, BC equals 40 and millimeters, CD equals 50 millimeters, DE equals 70 millimeters, and EA equals 55 millimeters. Angle CAB and EAB are 135 degrees and 120 degrees respectively. So let's make sense of that and put that drawing in AutoCAD. Alright, so here it says that AB is 50. So we're going to start with AB. First, let me ensure that I'm drawing in the correct unit. I want to ensure that I'm drawing in millimeters and not feet and inches. So let me type the units. Alright, I am in millimeters. Let me just set my precision to 0 because I don't want any decimals. Alright, good. Alright, so I'm going to start with line AB. I'm going to turn on ortho and I'm going to set AB to 50. Alright, so there I have a line AB. Okay, so now with AB there, it says here that BC, alright, is 40 and angle CBA is 135 degrees. So this angle right here is 135 degrees. All right, so being that this is 125 degrees, to find what we're actually going to draw this line at, all we have to do is to minus 90 from 135. Why would we minus 90? Because we're going to be drawing the line in that direction, going in that direction like that. So right here would have a 90 degree line. So this entire angle is 135 degrees. So let's say we have a 90 degree line here. All right, then the distance that's left is what we need to find out from the 135. So what we're going to do is to minus 90 from 135 and we're going to get 45. So we're going to draw this at a 45 degree angle. Okay, so let me just turn off ortho. I'm going to turn on polar tracking. I'm going to set this right here to 45 and then I'm going to draw this right here. That green line tells me that that's a 45 degree angle, and then now I can just type the distance, which is 40. It says that BC is 40, so that's BC right there. And I can check to ensure that this distance is 135 by coming over here to utilities, measure distance, and I'm going to just click on, we'll do that again, utilities, measure, sorry, not distance, angle, and I'm going to click on this line here and that line there, and right here it says the angle is 135 degrees. So we know that's good. All right, so we have A, B and C, and we can start to label those. So let me select text here, click the drop down arrow and select a multi-line text, and I'm going to create like a little box, and then I'm going to type my text here. So let me type A. All right, so let me just make this with a different color, like a bright lime green color, and then I'm just going to copy this from here. Okay, and I'm going to bring that here. So that's A, this will be B here, and then over here we will have C. Good. So let me just change this value from A to B, and then let me make this C. All right, now so to finish off our irregular pentagon, it says that the angle EAB, this angle right here, is 120 degrees. All right, and it says that EA equals 55 millimeters. So we need to draw this angle here, which is 120, and then make EA 55. All right, so let's do that in AutoCAD. So it's 120, so all you have to do is to come over here back to polar tracking, click on the drop down arrow, and as you can see, we can set this to 120. So we could go here where it says 30, 60, 90, 120, or we could go into tracking settings and we could change this, the increment angle, to 120. So we could do that, or we could just also select this right here where it says 30, 60, 90, 120. So we could do either. All right, so now I'm going to click on this line. I'm going to select a line, sorry. Click at point A, and that green line there tells me that that's the 120 angle once you have polar tracking turned on and you set the increment angle to 120. And it says that this is 55, so we're going to make this 55 millimeters and press enter. So over here now we have point E. So let me label this point E. All right, nice. All right, so now the next thing we need is D. Okay, and it says that CD equals 50 and DE equals 70. So we don't know these angles, but we do not need to know the angles. All we need to know is the distance from C to D and the distance from E to D, which we do know. So D to E is 70. All right, so what we're going to do now, knowing that D to E is 70, we're going to select a circle. We're going to come to point E, and we're going to draw this circle with a radius of 70. Let me just select like a lighter or a darker line, well, darker circle for the construction. All right, so this is going to be 70. The radius of the circle is going to be 70. All right, so that radius right there is 70. All right, I could just type 70. Well, I did just type 70 because my computer in my AutoCAD, my circles are set to radius, but yours might be set to diameter. So to ensure that you do the radius, you can do R enter, and then you do 70 enter to ensure that you're getting the radius and not making the diameter 70. All right, now we're going to have to find CD. All right, and it says here that CD, line CD, equals 50 millimeters. So just like we did from E, where we drew that circle with a radius of 70, from C, we're going to draw a circle with a radius of 50 millimeters. So let's just come to C, select a circle, and I'm going to draw this circle with a radius of 50 millimeters. All right, so now where these two circles meet right here, that is point D. So we can connect that point to E and C. So from here, I'm going to connect E to this point right here, and that's point D. And I'm going to connect D to point C. All right, so now all I have to do is to label this D. So I'm going to copy this here. I'm going to bring this here and call this now point D. All right, so with that, we have finished. We have completed the drawing of our pentagon. So now we need to figure out how we're going to draw a triangle equal in area to this pentagon right here. And it's a two-step process. So it says that for step one, for stage one here, it says you're going to join D to A. So join D to A right here, and then produce AB to F and draw EF parallel to DA. All right, so what that means is this: we're going to draw a line from D to A, then I'm going to draw this line BA here, I'm going to extend it out, and I'm going to draw a parallel line from D to F right here. All right, so that's what we are going to do. So first things first, I'm going to use a dark line because it's construction. So I'm going to draw this line from point D to point A. All right, good. And then I'm going to extend point A. So this is point A right here. So this are AB, I'm going to extend AB. All right, so let me extend AB. No specific length, really. Let me turn on ortho to ensure that it is completely horizontal, and just extend AB like that, no specific length. All right, so now what we're going to do is to draw a line from E to touch this line that is extended from AB. All right, and that line is going to be parallel to the line DA. So all we have to do is just click on this line DA, select the copy tool, or just type C, enter, copy the line from there, bring it to this point here at E, and there we have it. So now what we don't need, we can trim. So we can trim. So I'm going to trim off any excess that I have here. Let me trim that, and this I can delete. All right, good. So now over here, this point that we get would be point F. All right, so that point right there would be point F. So let me label this point F. All right, nice. So that's point F. Now with that, it says that we're going to draw DF, draw this line DF here to give a quadrilateral equal in area to the pentagon. All right, so first we're going to turn the pentagon into a quadrilateral of equal area, and then we're going to turn the quadrilateral into a triangle in stage 2. So to finish turning the pentagon into a quadrilateral of equal area, what we're going to do is to join D to F. Okay, so we have D and F, so we're going to join D to F. Let me use a solid line and not a construction line here. So here we would join D to F. Alright, so there we have this line DF. Alright, good. So then now, once we have done that, we move on to stage 2. And in stage 2 it says this is what we're going to do. It says we're going to repeat for points B, D, G, and C to give a triangle equal in area to the quadrilateral. So what that means here is that we're going to join B to D, all right, and then we're going to extend B, BA here. We're going to extend B, and we're going to get point G right here, and then we're going to join D to G. So let's see how we go about doing that. So the first thing we would do now here is to select a line. I'm going to use a construction line for this. So I'm going to join point D to point, I'm going to join point D to point B. Alright, then I'm going to extend line AB over here. No specific distance, like that. And then I'm going to draw a line from C that is going to be parallel to DB. It's going to cut the line that we just extended from CB. Sorry, the line that we just extended from AB. All right, and that's going to give us point G. So I'm going to click on this line that I just do from D to B. I'm going to select the copy tool or type C, enter, and I'm going to click on that line from right there, and I'm going to bring it to point C. All right, now when I bring it to point C, now I can trim off the excess that I don't need. All right, good. And then now the next thing we're going to do is to, so here now we would have found the point G. So let's label point G. Let's show point G a little bit of respect. All right, so here this is point G. So then we're going to join D to G with a solid line. All right, so I'm going to join D to G right here. Now the triangle that we have now that is equal in area to the pentagon is triangle DGF, as you can see over here, triangle DGF. So now we can hatch that just to show the triangle. So let me do that. You don't need to hatch it, but let me hatch it to just show the triangle. So let me select the hatch tool. You can just type H, enter, or hatch, or you can select the hatch tool over here, and I'm going to select a solid hatch. So let me select a solid hatch. Just click on the drop down arrow beside hatch and select solid hatch, All right, so I would arch right here, I would arch here, I would arch there, 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 and here. All right, and that is the triangle. This is the triangle equal in area to the pentagon that we started with. All right, so that is how you would go about drawing a triangle equal in area to a pentagon. Thanks for watching the video, and do have yourself a wonderful day. If you enjoyed the video or found it useful, please drop a like and subscribe. It would be massive. Thank you so much for your support, and have yourself a wonderful day.